Okay, so good morning, everyone from Brazil. My name is Alexandre, and I'm very happy for the opportunity of sharing my project in collaboration with Professor Rafael Parpinelli, entitled Financial News Effect Analysis on Stock Price Prediction Using a Stacked LSTM Model. So I'll briefly introduce the problem and motivation of the study, explain our proposal and its methodology, and finish the presentation demonstrating our experiments and analyses, final considerations, and future work as well. So the idea of attempting to predict prices on the stock exchange is not something recent. The desire to be able to predict market movements is intrinsic to basically any investor and drives this large area of research. Although the financial market is very profitable, it is also extremely volatile. There are several factors that influence the price of an asset, and one of the most important are financial news about companies on the stock exchange. Something important to note is that these news are available to the general public. This vast amount of indicators makes predicting prices an extremely complicated task. So the objective of this research is to contribute to the literature with the investigation of strategies and also the implementation of a price prediction model that is evaluated in a real investment scenario, seeking to analyze the possibility of making reliable predictions. So the interest of retail investors in the financial market is constantly growing, and is a fact. But unlike banks and large capital management companies, these small investors have few tools to guide their investments, let's say. So leaving all decision making in the hands of this investor can become a little bit overwhelming for them, given the vast number of influencing factors on the volatility of stock prices. So the solution to this problem is to abstract this difficult decision making using some sort of computational intelligence. And the purpose of this research is to develop a strategy for predicting stock prices using a machine learning model based on the artificial recurrent neural network long short-term memory, or in short, LSTM. And our model has a strategy of sentimental analysis attached to it, which classifies news from the New York Times newspaper to assist the predictions of prices in the period studied. The news sentiments are calculated by the Valence-Aware Dictionary for Sentiment Reasoning, or VADER framework. Now, speaking a little bit of methodology, the test scenario we considered is based on a period of 5 years, from 2016 to 2020. The stocks analyzed are those that compose the top 50 of the S&P 500 index, using indicators from the first quarter of 2021. And for each year, the 500 most relevant news with the finance theme in the New York Times were extracted for each asset in question. And the historical series from the prices were extracted from the Yahoo Finances platform. Quickly showing the architecture of the prediction model, it has a total of 4 layers, one input, one output, which are standard, and 2 LSTM layers stacked as hidden layers. So the number of 2 LSTM layers was established empirically, and during those experiments, we found that adding more layers generated a somewhat insignificant improvement in the accuracy of the model, but it also made it increasingly computationally expensive. So it doesn't make sense to keep adding more layers. The abstraction of 2 LSTM layers is good enough to solve the problem in our nature. So as stated before, the complete model has 2 features in each input sample. So the sentiment value and the stock price. Basically, each sample contains the information of a range of D days and outputs the predicted value for day D+1. That's the basic idea. We designed 3 sets of experiments to reach our objective, and the first step is not necessarily an analysis, but more of a necessity to the research. because when working with machine learning models, the tuning of such models always imposes a challenge. We tackle the tuning with an algorithm called hyperband, in which we subjected some of the model's hyperparameters to be fine-tuned. The second step, in summary, is running the model with and without the sentiment values as a feature, to analyze if this feature in fact helps or not the model in creating more accurate predictions. And the final step with the model tune, and after understanding the impact of using sentiment values as a feature, we use the model to create predictions outside of the training and validation scopes and apply these results in a real investment scenario. So in order to properly evaluate the model with and without the sentiment values as a feature, we used hyperband to tune the model in these two different scenarios. So this table shows the 5 best configurations generated by the procedure for the model without considering sentiment values. So with these 5 configurations, we trained the model 50 times for each of them and calculated the MAPA metric for every run. And the top 3 configurations, you can see that they have pretty similar results. Therefore, we decided to run the ANOVA test with 1 factor, and furthermore, the 2K HSD key test to confirm with 95% of confidence that configuration 1 statistically produces the best results. And similarly, we do the same procedure, but this time for the model considering sentiments. So again, we take the 5 best configurations generated from hyperband and run them 50 times each. And with the same statistical test procedure, we can also guarantee that for this scenario, the configuration 1 was the best. So with the models properly tuned, we can begin the second step of the experiments, which is testing the impact caused by the sentiment values feature. So in our scenario of application, the results, again, running the algorithm 50 times and collecting the average, but this time for the RMSE metric, not the MAPA. So the results, they show very clearly that applying the sentiment values as one of the model's features increase the accuracy according to the metric calculated. And furthermore, to check if the model was actually properly configured by hyperband, we plotted the training and validation loss curves, and we identify a very positive behavior. They display a small gap, which is completely normal between them. And we also have the proper convergence displayed on the graph. So with everything in our hands, the final step of the experiments is to actually verify if the model is able to accurately predict prices into the future, being days that aren't in the training or validation scopes of the input data. So in order to achieve this, we use the model with the sentiments as feature that produce the best results. And we generated 50 data points which actually represent the 50 first days of the 2021 stock market, and selected a number of tickers to compose a investment portfolio based on a risk measure called CVAR. So I'm not going to explain exactly what CVAR does, but the idea of using CVAR is because in a realistic scenario, we wouldn't have the real values for the stock price of those 50 days predicted. And not having the real values make it impossible to calculate the RMSA. And therefore, a different approach has to be used to rank the predictions from best to worst, let's say. And this is why a risk measure like CVAR comes into play. And this predicted portfolio was then compared with the real values for those 50 days to simulate an investment scenario. Again, in a real scenario, those real values wouldn't exist, but in an experimental scenario, we actually have them, but we didn't use them for anything other than comparing the result. That's the important part. And Here I display the results for a portfolio with cardinality k equals 3, which essentially means that the portfolio has 3 tickers, and the results are rather promising. I'm just summarizing here, but on our paper we have more analysis with cardinalities 5 and 7, but I just brought the cardinality 3 for the presentation, but the analysis can be expanded to all of the scenarios, and we can see that up around 35 days, the predicted values, they maintain a very good accuracy compared to the real values. And after this point, the accuracy collapses rather quickly. Ever since the beginning of the project, we understood that creating such predictions and maintaining a high accuracy through a long period of time was a very ambitious task, but we are very happy with the results and understand that they still even have potential to be better. So due to various factors that influence the price variation of a stock, the task of predicting these movements is rather complex, but our work proposes a robust prediction model, which uses as attributes the sentiment of financial news related to companies and also their respective historical price series. So 2 features. And the results indicate that the model benefits from the application of the sentiment attribute, which is a really good thing for the research in general. And also, according to the scenario studied, the model with this indicator stands out over the model without the indicator, with optimal parameterization approximated by the Hyperbane algorithm. The model is able to make reliable predictions, evidencing the performance of the predictions in a real investment scenario, where the shares contain an extremely volatile behavior because, well, mainly due to the influence of the COVID-19 pandemic on the financial market in that period. And the results statistically indicate that the predictions are reliable up to around 35 days into the future, which is a mark where the model accuracy starts to collapse rather quickly. But even with the display of good results, there are aspects to progress, and we understand that. So basically, adding more indicators to the model, it can be very interesting, considering the fact that the addition of the investor sentiment attribute brought great results. Furthermore, we believe that a period of 5 years is good enough to demonstrate the implemented model, but a more realistic investigation could use a longer period with more samples to work with. And finally, the approach was built with the objective of generating predictions as far into the future as possible. But many investors nowadays are working with day trading, modifying the model to not only encompass, but maybe even just work with day trading. It could bring very interesting results and completely different analysis from what we brought today. Yeah, so I appreciate the opportunity to share our research with everyone here, and my contact is on the screen if anyone wants to discuss things a little bit further. And I'll open now for a couple of quick questions. So thank everyone for the attention.
Thank you. I'm sorry, I think I totally mispronounced your first name. I won't try it again.
No, it's okay.
Olaf raised his hand. Okay, your question first.
Sorry, thank you for the interesting presentation. And yeah, I have actually 2 questions. Maybe the first one is an easy one. You said sentiment improved your model and showed that to us. My question was just, did you measure the accuracy of your sentiment analysis of radar in your data? How accurate is your sentiment prediction?
Yeah, we use the Vader model as a framework to calculate the sentiments, and I believe we extracted 500 news from each one of the 50 tickers, so we don't have many gaps considering at the time series analyzed because 500 news from each year. It technically means that we have at least more than one news for each data point. It actually in a statistical matter, right? Because on a practice matter, it doesn't necessarily means that statement doesn't necessarily hold true, because, well, you can have 10 news in a day and 0 in another, but in average, it creates a data set with not many empty points. And even if there was an empty point, we just
sorry to
estimated
interrupt you. No, I'm sorry, maybe I said it in the wrong way. My question was, if you have just one data point, so one news, you used radar to predict the sentiment. Did you measure if the sentiment using the framework was correct or not correct, and how many of the sentiment predictions were correct out of all the predictions? I really mean the sentiment.
Okay, yeah, we use the benchmarks as to predict, but there's not necessarily a correct sentiment or not, because those news, they weren't exactly in a controlled environment, let's say, because we extracted those news live from the New York Times platform. So I don't think there's a correct number for this sentiment, but we believe that the Vader framework is well tested, and we believe that the results have a great accuracy.
Yeah, I'm asking because I do research work in the field of social media and sentiment prediction, and I know that there can be a lot of errors. That's why I just wanted to know if you checked that. Maybe you can later have a look at it. I think it's a good information to add to your research, how accurate your sentiment prediction is. And my second question, when I look at the time, maybe we don't have too much time to really answer everything. I just wanted to know if you compared your model or your approach at the end with other already existing and published approaches, and maybe with very few words, what is the benefit of your approach compared to these other approaches?
We didn't compare yet, but we are working on it.
Okay.
I mean, to extend our research. This was basically my master's degree thesis, but we are still working on a bit of improvements, and we have a roadmap to compare with 2 or 3 state-of-the-art technologies. LSTM is also a state-of-the-art technology on this field, but we didn't, but we have the plans to be doing so, yes.
Okay, thank you.